Your mic is muted.
So I'm saying good evening, and I'm very happy that so many of you are present today.
Good evening, ma'am.
Exams all over. Okay. So this is where we stopped in the last class. So many of you are there. Ashwin, how are you?
I'm fine, ma'am.
Sanjay, how are you? Sanjay, are you there? Sanjay, how are you? Fine. And Vishal, how are you?
Fine, ma'am.
Did you read through the textbook to understand what is happening? Vishal?
Yes, ma'am.
Did you read through the book to understand what is happening?
Yes, ma'am.
Sai Kalyan, how was the exam? How were your exams, Sai Kalyan? Hello? Sai Kalyan, you have not, your audio is not connected. Hello? Hello? Okay, so I'll start now anyway. Last two classes I cancelled because many of you were not present. So in the last class, we finished doing we were doing a rechargeable cell of, we did this, the cell which we call a secondary cell. And the secondary cell that we were doing was a lead accumulator. The lead accumulator cell is what we were doing in the last class. So today we are going to continue with the remaining cells I will do at the end of the lesson. I realize it is at the end. So today we are going to do what we call electrolysis. So last class, many of you were not present. So I am going to repeat this part of electrolysis to you. So electrolysis is that part of electrochemistry where you use electric current to bring about a reaction which would not take place otherwise. Okay, so in electrochemistry, what did we have? We had two separate compartments, one in which you have an anode, metal dipped in its own salt solution. So you had zinc, say for example, zinc dipped in zinc sulfate, and the other, that was the oxidation half of the cell, and then you had a reduction half of the cell where you had another metal like copper dipped in copper sulfate solution. And when you connected them both, there was a flow of electrons. And because of that flow of electrons, the electricity was generated. So naturally, from zinc has a tendency to give electrons and copper has a tendency to accept electrons. So electrons were flowing from zinc electrode to the copper electrode. So that was galvanic cells. All the cells that we learned there, they were galvanic cells which produce certain amount of electricity. Now here what we are going to learn is how you use electricity to bring about a reaction. So here you have an electrolyte, and that electrolyte is kept in a container which is known as the electrolytic cell. Okay, so you have a container in which you keep, this is the container, and in this container you have this cell known as the electrolytic cell. And you immerse two electrodes in the electrolytic cell. These electrodes can be positive electrode and a negative electrode. So which one is a negative electrode? Which is connected to the negative end of the battery. There is always a battery here. The battery has a negative and a positive end. So the electrode which is connected to the negative end of the battery, it is the negative electrode. The one which is connected to the positive end of the battery is the positive electrode. Then the electrolyte that you take, it should contain ions. So how will it contain ions? It will contain ions either if the electrolyte is in molten condition or if the electrolyte is in aqueous condition. So here I have taken molten sodium chloride. Solid sodium chloride does not conduct electricity because it doesn't have free ions. So if you want free ions, you have to melt it. And then ions, the force of attraction by melting, it breaks down and it breaks into sodium ions and chloride ions. So at the negative electrode, what happens? The positively charged ions will move towards the negative electrode. And negative electrode, why is it negative? Because from the battery, the electrons are coming in here. So this positively charged ion, sodium ion, which is a cation, it accepts electrons. It gains electrons and changes into sodium. And sodium is what gets deposited at the negative electrode. So this process of I have told you what is gain of electrons. Gain of electrons here, what is happening? What is gain of electrons called? Reduction is gain, isn't it? So gain of electrons happens. And so this electrode where gain of electrons happen, we have already learned earlier, it is known as cathode. Now what happens at anode? The negatively charged ions, which are the chloride ions, they give out electrons because what is the positive electrode? It is the electrode which is connected to the positive terminal of the battery. So it is deficient in electrons. So chloride ions, they lose their electrons here. There's a loss of electrons, and so chlorine is formed here. And so this electrode where oxidation, loss of electrons is what? Oxidation. And that is why it becomes the anode. So there is a loss of electrons, and so it becomes the anode. Now you see the next example that I am trying to teach you is the electrolysis of sodium chloride solution. So now again you have an electrolytic cell. And in this electrolytic cell, what happens? Again you put the cathode and the anode. Now all 6 are there. Sai Kalyan, now you can hear me. Can you hear me?
Yes, miss.
Yeah, earlier your thing was not connected. How was your exam?
Yes, miss, it was easy, miss.
Easy. Then what about you, Kalpakesh? For many days, I thought you have left. You had not come for many days. What happened to you, Kalpakesh? Madhavan?
Even I have exams in my school, ma'am. That's why.
Oh, so you were preparing. How were the exams?
Ma'am, not very easy, ma'am. A little bit you have to think and do, but it was fine only, ma'am.
Okay. Okay. Okay, so now we are trying to do what? We are trying to do the electrolysis of the um, sodium chloride solution. So when you do electrolysis of sodium chloride solution, what do we have? We have, can I put it? Yeah, this is better. Okay, so we have sodium chloride and NaCl. Sodium chloride, which ionizes to give sodium and chloride ions, and water, which ionizes to give H plus and OH minus ions. So whichever has higher reduction, because what is the process which happens at cathode? It is reduction. So when reduction happens at cathode, the one which has higher reduction potential gets reduced at the cathode. Now here the higher reduction potential is of iron, of hydrogen. So hydrogen has a higher reduction potential compared to sodium. So it is not sodium, but hydrogen which gets reduced at the cathode. And so hydrogen gas is formed at the cathode. Now what happens at the anode? The negatively charged ions, they move towards the anode. So it is actually water, and this is to make it easy to show you that there are negatively charged ions. So these negatively charged anions, they move towards the anode. Now, two things can happen at the anode. The chloride ions, they can get oxidized, or the water can get oxidized to oxygen. So whichever, this is the reduction potential which is given. So if I want to convert it into oxidation potential, then I have to put a negative sign here, whichever has a higher reduction potential. So oxygen has a higher reduction potential. So oxygen should be ideally discharged, but due to there is something called over potential of oxygen. In this case, chlorine is discharged. This question comes and give reason sometimes. Even though the oxidation potential is of oxygen is higher than oxidation potential of chlorine, still chlorine is discharged at the, or chlorine is oxidized at the anode. Why? Because of something which we call over potential of oxygen. So oxygen is not able to get discharged, and so it is chlorine which gets discharged at the. So this is the thing that we did at the end. Now we can do one more thing I wanted to show you here. Now this time what we are doing is, we till now in the previous two, we were using the electrodes which were using, they were inert electrodes. So what we call them? Inert electrodes. So the electrode doesn't take part in the reaction. So this is inert electrode. Okay. Now in the next example that I want to show you, here we have an electrolytic cell. This time we are doing electrolysis of copper sulfate solution. Okay, this is for you to understand what will get discharged at a particular electrode. So you take copper sulfate solution. So if you do electrolysis of copper sulfate solution and I use inert electrodes, electrodes will not take part in the reaction. This electrode here is connected, larger line shows positive. So this is the positive electrode. And what is the positive electrode? Positive electrode is the anode in this case. And this is the negative electrode, which is the cathode in this case. Always, whichever is connected to the negative terminal of the battery is negative. And here, since reduction takes place, this is cathode. Here, oxidation takes place. We call it anode. So what are the ions in solution when there are copper, when it is copper sulfate solution? What are the ions? CuSO4 will give what? Cu2 plus SO4 2 minus. And in addition to that, you have water. All right. So at the cathode, what is the possibility? The positively charged ions will move towards the cathode. So water, you can say, gives H plus OH minus. So what are the positively charged ions? Cu2 plus ions and H plus ions, right? Now H plus, you can say the reduction potential of copper is more than the reduction potential of H, right? H is always 0 and copper is plus 0.34. So whichever has a higher reduction potential, you can look at the values in the table. So for reduction potential of hydrogen is how much? 0.00 volts. And for copper, it is plus 0.34 volts. So copper has a higher reduction potential. So copper will get discharged at the cathode. So what will I write here? Cu2 plus, right? So Cu2 plus 2E minus, it gives you what? Cu. So copper starts getting discharged at the cathode. So what will happen? On the surface of the cathode, what will you find? You will find slowly after some time a layer of copper will get discharged, will form at the surface. Now of these two, the reaction that I wrote earlier, H2O giving, now here the water will get oxidized here. So water gives you O2. Okay, so O2 and it is 4H plus 4, 2H2O. We have to make O2. So 2H2O plus 4H plus 4E minus. This is the reaction that will happen at the anode. So what will be the product at anode here? It will be oxygen gas. Okay. And what will be the product here at the cathode? It will be copper. So if I take inert electrodes and I take copper sulfate solution, that anode, what will happen? Oxygen will be formed, because the oxidation potential of water changing to oxygen is much higher than the oxidation potential of sulfate ions getting discharged. So you will get oxygen. Now what will happen to the solution? Can anyone tell you? Tell me, why is this solution blue in color? Can anyone tell me why the solution is blue in color? Anybody? Please tell me, why is it blue in color?
Because copper sulfate solution.
Because copper sulfate solution, it contains which ion? Cu2 plus ions. Because of the copper ions, it is blue in solution, in
Yes, ma'am.
color. So now what happens? The copper 2 plus ions, they will start getting discharged at the cathode. So what is happening? Copper is changing, copper ions are changing into copper and getting deposited at the cathode. So what will happen to the color of the solution? Slowly, copper 2 plus ions will be used in making copper here. So the color will fade. So after some time, the blue color will fade. Why does the blue color fades? The blue color fades because the copper ions start getting discharged at the cathode. Okay, so this is now the last example that I want to teach you now. The last example that we will learn now is we are going to use now another electrolytic cell. And in this electrolytic cell, again, I am going to put copper sulfate solution. Copper sulfate solution. Okay. Who all have come now? Vaishnavi, Vishal, Ashwin, Kalpagesh, Sanjay, Sai Kalyan. How come there are 8? 1, 2, 3, 4, 5, 6, and 7. Okay. So this is the copper sulfate solution. Okay, I have taken copper sulfate solution, but now I have changed my electrodes. What are the electrodes? Now this is something you should listen carefully and understand. Now I have taken 2 electrodes, and these electrodes I have connected to my battery outside. This is negative and this is positive as usual. So this one is the positive electrode and this is the negative electrode. All right. But they are made of what? They are made of copper. The electrode is made of copper metal. Okay, this is also made of copper metal. Copper metal, which is inside copper sulfate solution. Okay, now if I pass electric current through it, what will happen at the cathode? So here we have the cathode. And the cathode, what are the ions which are present? There are Cu2 plus ions and H plus ions. And like in the previous case, what will happen? Cu2 plus ions will accept electrons and they will change into copper. How will I show changing into copper? This copper will start getting deposited here. Right? So there was already copper in the electrode. Now copper will start getting deposited here. Now what happens at anode is more interesting. Now at anode, right, the reduction potential of, copper, here at the anode, the reduction potential of copper was higher. Now if I say, see what is happening at anode. Anode oxidation should take place. So ideally water or sulfate ions should go towards the anode and they should get oxidized there, right? But here when you have an active electrode means electrode which can take part in the reaction, like you have copper here. Then copper starts giving, copper itself, it starts giving electrons Cu2 plus 2E minus, right? So the oxidation potential of copper is higher than the oxidation potential of water changing to oxygen or sulfate ions getting oxidized. So copper gets oxidized. So it is copper which gets reduced at the cathode and copper only which gets oxidized at the anode. So copper changes into Cu2 plus. So what is the reaction happening at the anode? Copper ions are continuously getting formed at anode. And what are these copper ions going in the solution? And then they are getting deposited at the cathode. So after some time, what will happen to the copper electrode? Copper electrode slowly will start diminishing in size. So what will happen after some time? At the anode, what will be the observation? The mass of electrode, what will happen to it? Mass of electrode will reduce. And what will happen here? The mass of electrode will increase. Why is the mass of electrode increasing here? Because copper is getting deposited. Why the mass of electrode is reducing here? Because copper is going into solution. And even after some time, the copper ions will remain always in solution because they are continuously getting formed. So the color of the solution will not fade here. It will remain blue. As long as there is copper electrode getting into solution, the solution will remain blue in color. So what is actually happening? Copper is changing into, so what is happening at cathode? Copper is changing into Cu2 plus, right? By losing 2 electrons. And then it is going again. So this is happening here at anode. And then these ions are going towards cathode, and cathode, they are again changing back to copper. So this is the cycle which is happening. Copper is changing into Cu2 plus, coming here, from here to here, and then here to here. Now, if I make my, where does it become useful? If I make my copper, impure copper, if this copper is impure, and this copper here is pure, then what will happen? Impure copper will slowly change into pure copper. So this is an example of what you call electro-refining. Electro-refining. By this method, you convert impure metal to pure metal, because only the pure metal ions, they get into solution and then they get discharged. So whenever you do electrorefining, impure metal should always be the anode and the pure metal should always be the cathode. So in electrorefining, what do you do? Electrorefining. What is the cathode? Cathode is the pure metal. Okay. And what is the anode? Anode is the impure metal. And what is the electrolyte? Electrolyte is the aqueous solution of the salt of the metal. Okay. So this can be used for purification of copper. You can also use it for purification of silver. Like if you have silver here, pure silver which is pure, that can be cathode. Silver which is impure, right? That can be the anode. And what will be the electrolyte? A salt of silver, like silver nitrate solution. So like that, this process of electrolysis can be used for refining of metals. So that is the example of electrorefining. Similarly, you can do electroplating. Electroplating. You must have heard today. Who is the 8th participant? I am not able to understand. Vaishnavi is there? Find the participants. So 1, 2, 3, 4, 5. Vaishnavi has not come today. Okay. So electroplating, why we do? Because, sometimes you must have heard you take something which is gold plated. So you take that's why I was looking for Vaishnavi. Sometimes you make ornaments which are gold, but sometimes they are not gold. They are plated with gold, right? Or they are silver plated. Some inferior metal, but you plate it with silver. So electroplating is plating of one metal with the other. Like sometimes you see silver spoon. So the spoon is made of copper, but it is plated with silver. So when we do electroplating, what do you do? So in that case, you again have this electrolytic cell. And in this electrolytic cell, supposing I want to plate a spoon. So this is my spoon. And this is silver. The anode is made of silver. So this is silver. And this is the spoon to be plated, right? And you connect it with a cell. So this is the positive electrode, and spoon acts at what? As a negative electrode. And you fill in an electrolyte here. The electrolyte here will be what? Silver nitrate. Now, when you do electrolysis, what will happen? Silver will go into solution and form silver ions. And these silver ions, they will get deposited on the surface of the silver spoon. So they will get deposited here, right? So what will happen? The spoon will get plated with silver. So like that, inferior metals can be used, superior metals can be used for plating over inferior metals, and this process is known as electroplating, right? So all these are very, very useful processes and uses of electrolysis. Two main uses of electrolysis are electrorefining and electroplating, right? Now we will learn the next part of it. That is, supposing I pass electric current through an electrolyte, like supposing I take sodium chloride, solute sodium chloride molten, and I pass current through it. What will happen? After some time, some sodium will get deposited on the surface of this electrode. Now, how much sodium will get deposited on the surface of electrode, that we are going to learn now. So the next part that we are going to learn is Faraday's laws of electrolysis. Faraday's laws of electrolysis. Okay, so what does Faraday's law of electrolysis state? Faraday's law of electrolysis, there are two laws. The first law, what does it state? It states that the amount or the mass of the substance deposited at the electrode is directly proportional to the amount of current that is passed through it. Okay, so W is what? The mass of the substance. And is proportional to Q, right? That is the amount of, just 1 minute. So Q is amount of charge that is passed through the electrolyte. So what is the mass of substance deposited at the electrode proportional to the amount of charge that is passed through the electrolyte? What is this amount of charge equal to? Amount of charge is proportional. Q is equal to what? Q is equal to I into T. Do you understand this? Q is the current into time, right? So if I ampere of current is passed for T seconds, then the charge is Q. So Q is equal to I into T. You all understand this? Say something, children, while you are learning in the class. Do you understand?
Yes, ma'am.
Yes. So W is proportional to I into T. So what if I remove this sign of proportionality, then what is W equal to? W is equal to Z into I into T. Okay, Z into I into T. Now what is Z? Z is known as electrochemical equivalent. Electrochemical equivalent. Electrochemical equivalent. So what is the definition of electrochemical equivalent? The definition of electrochemical equivalent, how do we arrive at it? W is equal to Z into I into T. If I is equal to 1 ampere and time T is equal to 1 second, right? So what will W be equal to? W will be equal to Z, right? So what is the definition of Z? Z is, or you can say Z is the electrochemical equivalent. Electrochemical equivalent, which is equal to the mass of the substance deposited at an electrode when 1 ampere current is passed through the electrolyte, for 1 second. Okay, so if I pass 1 ampere current through an electrolyte for 1 second, the amount of substance that will be deposited at the electrode, that is known as the electrochemical equivalent for that substance. For each substance, the value of electrochemical equivalent is different. Now let me explain this further. Now supposing I have sodium ion, 1 sodium ion, 1. Then I take 1 electron. it will change into one sodium atom, right? So for making one sodium atom, how many electrons did I use? One electron. And so for sodium, I needed one electron to change it into sodium atom, right? Now, if I take 1 mole of Na plus ions, right? How will I need, how many electrons I will need? 1 mole of electrons, right? It will give me how many sodium ions, atoms? 1 mole of sodium atoms. Did you understand? What is the meaning of 1 mole? What is the meaning of 1 mole? 6.02 into 10 raised to 23, right? Atoms, right? So, what is the mass of 1 mole of sodium atoms? It is 23 grams of sodium. Okay?
Ma'am, can you
Mass
show the
of
before
1 mole.
slide?
Yes, what?
Ma'am, can you show the before slide?
Previous slide.
Also, can you say that first law in sentence, like mass of substance deposited, and after that, can you say?
Z is the electrochemical equivalent, which is equal to the mass of substance deposited at an electrode when 1 ampere current is passed through the electrolyte for 1 second.
Oh, okay.
Okay.
Yes.
Okay. So now, did you understand this? So if I take one sodium atom, it will require one electron to make one sodium ion. It has one positive charge, so it will need one electron to give you sodium. All right, to give you sodium. So 1 mole, or what is, if I take 1 mole of sodium ions, it will need 1 mole of electrons. Okay, and it will produce 1 mole of sodium atoms. What is the mass of 1 mole of sodium atoms? It is 23 grams of sodium atoms. 23 grams of sodium atoms. What is the charge on 1 mole of electrons? The charge on 1 mole of electrons is 96500, sorry, 96500 coulombs. 96500 coulombs is the charge on 1 mole of electron. 1 electron has charge. For 1 electron, the charge is 1.6 into 10 raised to minus 19 coulombs. So charge on 1 mole of electrons will be equal to 1.6 into 10 raised to minus 19 into 6.02 into 10 raised to 23. So if I do that, I get 96500 coulombs. So 1 mole of electrons of sodium will be discharged by 96500 coulombs of sodium, right? So if I pass 96500 coulombs of charge, then how much of sodium will be discharged? 1 mole of sodium, or 23 grams, or the molar mass of sodium will be discharged when I pass how much current? 96500. Right? Did you understand from here? So 1 coulomb, if I use 1 coulomb, then how much of sodium will be discharged? 1 coulomb will discharge. I will write it properly in sentence. 96500 coulomb discharges 23 grams of sodium. So 1 coulomb will discharge 23 divided by 96500 grams of Na, right? And 1 coulomb the mass which is discharged by 1 coulomb of charge, that is the electrochemical equivalent. So Z for Na is equal to how much? 23 divided by 96500 grams. Grams per coulomb we should write. So I will just leave it at 965. 23 divided by 96500. Okay, grams per coulomb. The unit will be grams per coulomb. Okay. Now supposing I do the same thing for say copper. So in case of copper, what happens? Cu2 plus 2E minus gives you Cu. So to deposit 1 mole of copper, I will need 2 moles of uh, electrons. For 1 mole of copper, how many moles of electrons do I need? 2. So how will I write here? 2 into 96500 coulombs, COLOUM, coulombs. Discharge how much? Discharge 1 mole of copper. What is 1 mole of copper? 63.5 grams of Cu. So 1 coulomb will discharge. Will discharge how much? Will discharge 63.5 divided by 2 into 96500. All right, grams of copper. So this value here is what it is equal to Z. That is the electrochemical equivalent. What is the electrochemical equivalent? Which is the mass of the substance which is discharged when 1 coulomb of current is passed through it. 1 coulomb is what? 1 ampere current passed for 1 second, or 1 coulomb of current. Now supposing it was aluminium, Al3 plus, then how many electrons would I need? I would need 3 moles of electrons to discharge 1 mole of aluminium, right? So how would I write the same reaction? Z for aluminium now, you can write easily. Z for aluminium will be what? It will be equal to 27, which is the molar mass of aluminium, divided by 3 into 96500. So by doing this for different elements, what is the general formula for Z I have found? Z for an element is equal to atomic mass divided by valency into 96500, right? So my Faraday's first law, I can write it like this. W is equal to, what is W? The mass of substance deposited at an electrode is equal to atomic mass into I into T divided by 96500 into valency of the metal, whichever is getting deposited into valency. Okay, so this is the formula for the first law. This formula is not given in your book. I am giving you this formula because they have shown all these derivations. In this derivation, I have changed it into this formula. This will help you in finding the answer very easy. So let us do 1 or 2 questions to understand how we can do this. My camera is also off. Just 1 minute, I am setting my camera right. Not working even with this. Now it is. Just a moment, children. I'm going to start again. Just one. I'm just picking up a question for electro from your. Okay, so let us do this question. A solution of copper sulfate. A solution of copper sulfate is electrolyzed for 10 minutes and 10 minutes with a current of 1.5 amperes, right? What is the mass of copper deposited? What is the mass of copper deposited at the cathode? Okay, so you have to do this question. So what is the formula that we have? W is equal to, the formula is simply Z into I into T, which for Z I have simplified this formula and put it for you. So for the simplified formula, what is it? W is equal to atomic mass into I into T divided by valency of the element into 96500. So what will W be equal to? Now substitute. Atomic mass of copper is given as 63. 63 into I 1.5 amperes into time is 10 minutes. So time should be in seconds. So 10 into 60. What is the valency of copper? 2. The charge on copper ion is 2, right? Into 96500. Okay. You can take it as 96500 or you can take it as 96. Sometimes it is written as 96487. Whatever value is given, I have rounded off so that it becomes easy. So if you do this calculation, you will get.
Ma'am, will time not be 600? Like 600?
It will be 600 because 10 minutes are given, no?
Ma'am, because you written 60, that's why I asked me.
60, 10 into 60, no? Is
No, ma'am,
600.
time given 10 minutes now, ma'am. So each, oh, okay. I know.
See, it is 600 only, no? I have changed time 10 minutes into 60 seconds. It should be in 60 seconds, no? So what you are
Oh,
saying?
okay.
Time,
Yes, ma'am, understand.
So what will you get? The answer comes to about
0.29 grams.
0.29 grams. Okay, did you understand? All of you got it?
Yes, ma'am.
We'll do one more question. These are very easy questions. I will just twist it a little and give another one to you. I don't have a question ready. Just 1 minute. From your book only. So a similar question only is there, but anyway, you do it. It is a solution of nickel nitrate, a solution of NiNO3 twice is electrolyzed using 5 ampere current, using 5 ampere current for how much time? For 20 minutes. Okay, 5 ampere current for 20. What is the mass of nickel deposit? Nickel deposit. How will you do this? Just quickly do it and tell me the answer. Is 31. All of you try it out. The atomic mass of silver, of nickel. You can take nickel as 58.6. Valency you can make out from here. So what will you get? W is equal to 58.6 into 5 into 20 into 60 divided by 2 into 96500. Sai Kalyan, you are quick. Tell me, what will you get?
1.825.
Yes, 1.825 grams. Okay, so this is a type very easy questions can be asked. Sometimes they may even ask you the valency of the compound. They say this much, this is the mass of the substance deposited. What is the valency of the element? So you can find the valency also, because here is your valency. So or sometimes they may ask you what is the amount of current which is deposited. So you can find the amount of current. For how long did you deposit pass that amount of current? So you can find out the time. So one of the different things in the formula, one of them will be unknown and you can find out that. So that is for Faraday's first law. Then what is Faraday's second law? Faraday's second law. Okay. The Faraday's second law relates to when somebody is saying something.
Miss,
Yes, tell me.
can you move to the previous slide, miss? Miss, the molar mass of nickel, the molar mass of particular elements should be given, no, miss.
Yes, it will be given. It will be given.
Okay, miss.
It will always be given in the question. You are not expected to know any molar mass. Okay. Now we will do the Faraday's second law. So what does the Faraday's second law state? Faraday's second law states that if the same amount of current is passed through different electrolytes, okay, if the same amount of current is passed through different electrolytes, then their masses, the mass of each substance deposited at the electrode is proportional to their equivalent weights. So it works out like this: W1 by W2. If there are two solutions, the mass of substance deposited at one electrode and the mass of substance deposited at another electrode is equal to E1 by E2. Okay, that this E1 and E2, what are they? They are equivalent masses, equivalent weight. Now tell me, do you understand what is equivalent weight? Equivalent weight of a substance. What is the equivalent weight? Equivalent weight is the molar mass for an element. You know, there are so many ways you can calculate equivalent weights. Equivalent weight of an element, it is equivalent weight of an element is equal to molar mass of that substance divided by the valency. Or if it is equivalent weight of an ion, then it is molar mass of the ion divided by the charge on the ion. So that is equivalent weight. So equivalent weight of, say, for example, equivalent weight of sodium will be equal to what? 23 by 1. So it is same as the molar mass. Supposing you have to find equivalent weight of aluminium, what will it be equal to? 27 divided by 3, that is equal to 9. Equivalent weight of copper will be equal to 63.5 divided by 2. Why? Because the valency of copper is 2. So depending on the charge or number of electrons that will be required to discharge that substance, that will help you to find the equivalent weight. So the weights of the different substances that are deposited at different electrodes, provided the same amount of current is passed through each electrolyte, then W1 by W2 will be equal to E1 by E2. Now here it is important to understand that the concentration of electrolyte is not important. It is the amount of current that is passed through. Amount of, not even current is wrong word to say, amount of charge. If the amount of charge which is passed through different electrolytes is same, then the weights which will be deposited will be in ratio of, will have same ratio as their electrochemical weights, as their equivalent weights. Okay, so there are sometimes questions based on this also. So let us do one or two questions of that type. So just one question we can do here also. Let me give you one question. So same quantity of current, same quantity of charge, I should say, charge is passed through silver nitrate and copper sulfate solution. Two solutions, silver nitrate and copper sulfate. Okay. So calculate the amount of, find the amount of copper, find the amount of copper deposited if mass of silver deposited is equal to 1.08 into 10 raised to minus 3 kilograms. Okay, and atomic mass of silver and copper is given. Okay, so silver is atomic mass of silver or molar mass of silver is 108 and that of copper is 63.5. So how will I do this? W1 by W2, that will be equal to E1 by E2, right? So what is W1? Let that be the mass of silver which is deposited. So I will put 1.08 into 10 raised to minus 3 divided by W2. That is what we have to find. That is a mass of what? That is a mass of am I making a mistake? That is a mass of copper. Okay. And it's proportional to second law is not there. There is no question based on this. It should be equal to 108, that is equivalent mass of silver, which is same as its molar mass, divided by 31.63.5 divided by 2. So that will be 31.7. Okay, so you can calculate W2. So W2 will be, you can calculate and find out what is the mass of copper that can be deposited. Okay. Okay, so that is for Faraday's second law of electrolysis. Did you all understand this second law also? There are no numericals in your based on this, but in case there is a numerical, you know how to find out. Okay, so that is about electrolysis, the two laws. So in electrolysis, what do you have to understand? That you pass electric current through an electrolyte. The positively charged ions, that is cations, they move to the cathode, and anions, they move towards the anode. Cations get discharged at the cathode and anions get discharged at the anode. So what will get discharged at cathode and anode depends on the reduction potentials. So if the one which has higher reduction potential will get discharged at the anode. The one which has higher reduction potential will get reduced at the cathode, and the one which has lower reduction potential will get oxidized at the anode. So this is the general thing. The mass of the substance deposited will depend on the amount of charge that is passed through it. You can calculate that and find out the mass of the substance that is deposited. And if same amount of current is passed through different electrolytes, then the mass of substance is directly proportional to the electrochemical equivalent weight. So W1 by W2 is equal to E1 by E2. Okay, so that is, these are the. So we are literally done with this topic on electrolysis. Now what remains here is what I had planned I was doing earlier, is the few things like this one. We did this cell, which is the secondary cell. I gave you an example of the secondary cell. And this is the one that we learned was lead accumulator. It is called lead accumulator. Okay, and this is the cell which we use, battery rather, combination of lot of cells, 6 cells, which we use inside a car or an inverter at home. That is a lead accumulator. Why do we call it a secondary cell? Because it can be charged and discharged. Like once it gets discharged, you connect it to an external source of current, it will get charged again. Then again it will get discharged, you connect it to the external source. So charging and recharging. It is not that once it is used, it is useless. It can be used continuously, charging by charging and discharging. They are called secondary cells. Now, in addition to the secondary cells, we need to learn some primary cells also. So there are certain cells which are primary cells, which can be used once and they cannot be used again. Okay, Sai Kalyan, you have given a, in your school, you have given a talk on this. So you should help me. It is, there are different types of reactions everywhere, but anyway, let me. So from this picture, you would have understood this is the type of cell that you use in your torch, and many of the toys, they make use this, the voltage. This is, they can be different types, AA, AAA, and all that. Voltage of this cell is about 1.5 volts. This is the amount of current it produces, 1.5 volts. Now here, it has an external jacket, which is a zinc cup, right? Which is, zinc is made of, an anode is the zinc. And in the center of this, you have a carbon rod, which acts as the cathode. Okay. Whenever you, there is a metal cap on the cell, on the top, you must have seen the cell is, if I draw it horizontal like this, this is the type, this is the way the cell looks, right? And here on the top, there is a, red cap sort of thing here in the center, right? So whenever you connect the cell, inside something, there is a spring sort of thing here, which connects to the base. This is the holder, and this snaps open. So this is how you complete the circuit of the cell, right? So in the center, you have the cathode out, which is made of carbon, and outside you have this cover, which is made of zinc. The base, that zinc base, you can see. Outside the zinc cover, you have, they cover it with cardboard, a thick cardboard. So it is protected like that. So what you see, the white cover, it is actually only made of paper or some cardboard. Now, what is filled inside? Inside, what is filled is what you call a paste of MnO2 and ammonium chloride. Inside here, it is written, as you can see, MnO2 and carbon black paste is there. Now, mainly in all the cells, what we have to learn is what is the reaction at cathode and what is the reaction at anode. Okay, so what is the anode? Let us learn that. So the anode here is made up of, I told you, anode is the place where what happens? Oxidation. This is the first thing that you should always write. What is happening at anode? Oxidation. And this is a galvanic cell. It has to produce current. So electrons should be formed at the anode. So what is the reaction? The anode is made of zinc. So Zn, it gives Zn2 plus 2E minus. This is the reaction happening at anode. Now, what happens at cathode? Okay. Now, there are different ways of understanding reaction at cathode. Basically, what happens is MnO2, in which manganese is in +4 oxidation state, it changes into a compound which we write as MnO and OH. If you look at this product which is formed MnO and OH, what is the oxidation state of manganese here? Oxygen is -4, this is +1, so manganese is +3. So the oxidation state of manganese is changing from where? From +4 to +3. So it is getting reduced. So here what is happening? Reduction. And to write the balance, to balance this equation, you have to make use of ammonium chloride also. So ammonium chloride gives ammonium ions. And these two, they combine with E minus to give you here NH3. Okay, so this changes into ammonia. And that is why when the cell decomposes or something happens, at that point of time, you will get the smell of ammonia. Now this ammonia doesn't come out, is not able to come out as gas. So this ammonia, it combines with zinc ions. So zinc ions and this ammonia, they combine and form a complex, which is ZnNH3 whole 4 2 plus. It becomes a complex ion, right? So it remains there. So as long as MnO2 is there, slowly MnO2 is being used and it is changing into, actually it forms another oxide of manganese, which is Mn2O3, but we always write it like this to balance the equation. So as long as manganese is there, it will continue to produce current, but slowly all MnO2 gets over and all the ammonium ions, they change into this. And then what happens? And zinc is also started, getting consumed and changing into Zn2 plus. Then the cell becomes useless after some time. So if you leave this cell connected, yes, tell me.
Ma'am, after that ammonia gets combined with the, ma'am, like you said, the smell that is coming out now, ma'am.
No, when the cell is completely, see what happens is, supposing I don't disconnect the cell. I have just kept it red in the torch. You keep the cell here and you switch on and you leave it there. Then what happens? The reaction will continue inside the cell. Then the cell will get consumed and still reaction will go on. I mean, reaction will stop after that. But then what happens? The zinc at the base, there will be perforation in the base. So the paste will start the smell will start coming out, because some ammonia will come out. Some ammonia will combine with zinc and form this complex. Some ammonia will come out. So that is that little smell that you will get when the cell has got completely discharged. You must have seen, if you keep the cell inside some instrument that you are using it, keep it inside and don't use it. After some time also, the cell gets not only discharged, but it starts leaking. Have you seen a cell leaking? Leaking, why does a cell leak? It leaks because the hole is created in zinc. Why is hole created in zinc? Because zinc is continuously being used up. So there is no more zinc. Zinc is all in the form of Zn2 plus ions. So there is a hole, which is small holes are created on the base. And so this zinc complex which is formed and some ammonia, it starts coming out from that hole. So that is why the cell gets useless. So if you keep the cell connected, if you are not using something for a long time, what should you do? You should remove the cell and keep. So if you keep the cell connected, then the cell will completely get discharged till a hole is formed, because zinc, a thin layer of zinc only is there as the cathode, as the anode. So that gets consumed and so hole is formed. So this is a simple cell which is called the Leclanche cell. Not Leclanche cell. This cell is a Daniel cell. The first one is primary cell. This one is a primary cell. Why it is primary? Once discharged, you can't use it again. Similar to this is This is a mercury cell. Okay. Now, what is the problem? What is the, now this cell is quite large in size. So now we use mercury cells, which are also known as button cells. Okay, so now in many of the, earlier we used to have wristwatches where you used to wind, and every day one job was to wind the wristwatch so that it works. But now we have small button cells inside the wristwatches. The latest is you have wristwatches which get charged by a small solar cell which is inside the cell. So mercury cells or button cells, they are very tiny. Hearing aids, they make use of very small cells. Many instruments, they make use of these button cells. The good thing about button cells is that they don't get decomposed like the Daniel cell that I showed you earlier. So button cells, what is the thing here? You can see here, you have inside this, there is a, anode cap. This is anode, and the anode is made of, let me show you what is the anode made of. So anode is made of amalgam. We call it an amalgam, zinc and mercury. And the cathode is made of carbon and mercuric oxide, HgO. And electrolyte is potassium hydroxide and zinc oxide. Now, how does the reaction happen? So the reaction at cathode and anode. So first let us write the reaction at anode. The reaction at anode. Now all these reactions, children, you will understand if you know how to balance the ionic equation. Do you know how to balance the ionic equation, all of you? Tell me, do you know how to balance ionic equations? Yes or no?
No, ma'am.
I can't hear you.
No, ma'am.
No,
Okay,
ma'am.
okay. So at anode, what happens? Let us see how to balance the ionic equation first. So at anode, what happens? Zinc changes to zinc oxide. Now you have to balance this equation. How do you balance the equation? The first step of balancing the equation is first you should balance the element other than oxygen. So zinc is already balanced. One zinc here, one zinc here. Then you balance oxygen. How do you balance oxygen? By writing the number of water molecules which is equal to the number of oxygen atoms. So how many oxygen are there here? One oxygen. So how many water molecules you will write? One water molecule, H2O. Now with once you do H2O here, what you have to now balance hydrogen. So you will write same number of H plus ions on the other side. So how many H plus? 2H plus. Now you have to balance the charge. Now there is 2 positive charge and here there is no charge. So what will you have to write? Plus 2E minus. So 2 minus and 2 plus, it will get this. Now next thing what you have to do is this equation, this electrolyte is potassium hydroxide. So that means you have to balance this equation in alkaline medium. How will I balance it in alkaline medium? Whatever is the number of H plus ions, same number of OH ions you add on either both sides. So how many H plus ions are there? 2. So you write plus 2 OH minus. And on this side also you write 2 OH minus. All right. Now you complete this equation, half equation, and write what is the equation? You will, it will be Zn plus 2 OH minus. I will leave water. Why? Because here 2 H and 2 OH will make 2 H2O, and 2 H2O and 1 H2O on this side will get cancelled. So you will get Zn plus 2 OH will give ZnO plus H2O plus 2 E minus. Did you understand the reaction at anode? Okay. Same way you have to write the reaction at cathode. At cathode, what is happening? At cathode, you have HgO, mercury, and mercury will change. What will happen? Cathode HgO will get reduced. Cathode is reduction. So HgO will change into what? Hg. So let us write the reaction at cathode. Let me go to the next page and write the reaction at cathode. So same way we will balance the reaction at cathode. So what did we write? Cathode reaction is HgO changing to Hg. Now first we balance mercury, it is same. Now you balance oxygen. How will you balance oxygen? With water, 1 H2O you, sorry, 1 water, H2O you will write, H2O. Now to H2, you have to balance hydrogen. So you will write 2H plus on this side. Now I have to balance it with electrons. Balanced equation I got. Now this has to be balanced in alkaline medium because electrolyte is KOH. So I have to add as many H plus, same number of OH on this side. So 2 OH minus and same number of OH on the other side because I cannot add or subtract on the same side or both sides. If I add or subtract same thing, doesn't matter. So then I will rewrite this. It will become 2E minus plus 2H plus and 2OH will become 2H2O plus HgO will give Hg plus H2O plus 2OH minus. Now if I write this equation, finally this 2 and this 1 H2O will get cancelled. 1 H2O will remain. So what will be the final equation? 2E minus plus H2O plus HgO will give Hg plus 2OH minus. This is the reaction at what? Cathode. And similar reaction we had at anode. What was the reaction at anode? Zn plus 2OH minus giving ZnO plus 2E minus plus H2O. This was the reaction at anode, right? So what is the final reaction? This E get cancelled, this H2O get cancelled, OH and OH get cancelled. So what is the reaction? Which is very easy reaction. Zn plus HgO is giving what? ZnO plus Hg. This is the final equation for what? Mercury cell. So final equation is very easy. Zinc is getting oxidized, mercury is getting reduced. Okay. And we have to learn these steps because we should understand what is happening to the electrolyte. Why, how the electrolyte is helping. So in the presence of that electrolyte, zinc gets reduced, oxidized, and mercury gets reduced. All right. So that is the mercury cell. It works and it also produces a good amount of current. Okay. Now the next cell that we have to understand is the very important one, and that is called a fuel cell. Fuel cell. F-U-E-L. Fuel cell. Now this is the cell of future. Already it is being used. It is used in the space program. Okay. Probably we will use this cell for all our cars in future because this cell, what is the advantage of this cell? The advantage of this cell is it will continue to give power as long as the reagents are present. Now, what are the reactants here, or what are the what are the things which react. Basically, the reaction is between hydrogen and oxygen to give you 2H2O. And when hydrogen and water combine to give oxygen combine to give water, it produces current, which can be utilized. So this is the picture of a fuel cell. So you have this is the anode, which is made of carbon, and some special membrane is there so that the gas can diffuse through it. Similarly, you have anode, cathode and anode also it is made of this. You can see this is the anode and this is the cathode, and the reaction is taking place, and the electrolyte is hot solute. I mean, not necessarily hot, but it is potassium hydroxide. Electrolyte is potassium hydroxide. So here, what is the reaction at cathode and anode? Let us write down that. Okay, so this one is the anode. So first, let us write the reaction at anode. So at anode, what should happen? Oxidation.
I'm doubt now.
Yes.
But before equation, can you say it again? Like, what is that equation? Ma'am?
Which one?
The 2H.
This
No, ma'am. No, before.
No,
The 2H.
this here. This is the final reaction of.
Okay.
I will show you how this reaction happens.
Okay.
Hydrogen and oxygen will give water. So in this fuel cell, what we do is we take hydrogen, which forms what happens to hydrogen is what I'm going to show here. And on this side, we pump in oxygen. So hydrogen and oxygen, they diffuse and react with potassium hydroxide, OH minus. And while they are doing this, electrons get transferred from anode to the cathode. So first, when I write the reactions at cathode and anode, you will understand what happens. And these electrons, they go from anode towards the cathode. And byproduct of this is water. So when we use this in the space program, we are able to use it because in the space program, the fuel that you use is also hydrogen and oxygen. So that same fuel can be used to produce current. And the byproduct is harmless, that is water, which is actually used as water for the astronauts. So when you, in space shuttle and all, they use these fuel cells, okay? Normally now in a car, we are not able to use fuel cell because to compress hydrogen, it requires a lot of energy. You know, like for example, ammonia gets compressed very easily. We have learned in Henry's law. Ammonia gets compressed very easily because its KH value is very high. But hydrogen KH value is very low, so it does not get compressed easily. So if you want to make a hydrogen cylinder, it should be of a very thick gauge because you have to give a lot of pressure. You have to pressurize it to make it into liquid hydrogen. That is why it becomes difficult to use it in a car, because the cylinder which contains hydrogen and the cylinder which contains oxygen, they themselves are very, very heavy. So it becomes very unwieldy to take that cylinder to make a fuel cell. But now they are trying different ways where the hydrogen can be prepared inside. Instead of hydrogen, now they are using methanol for fuel cells. So there are new things happening. But for this fuel cell, I just want to show you the reaction. So at anode, what should happen? Hydrogen, what should happen at anode if it is getting oxidized? Hydrogen H plus, it should change into H plus, right? This is how hydrogen is getting oxidized. So here it is 0 and here it is +1, so it is getting oxidized. Now to balance it, you balance this like this, plus 2E minus. So this is what happens at anode. Hydrogen changes into H plus and 2E minus. Now this is again, like in the previous one I showed you, this is again in alkaline medium. So this OH minus, I must add as many H plus, I must add OH, same number of OH on both sides. So I will write 2 OH minus here and 2 OH minus here. So what will be the reaction at the anode? It will be H2 plus 2 OH minus. H2 plus 2 OH minus. Two OH minus will give you this 2H and OH will become on the same side. It will become 2H2O plus 2E minus. This is the reaction at the anode. What will be the reaction at cathode? At cathode, oxygen should be getting. Here at the cathode, what are we doing? We are passing oxygen. So oxygen should get. What is the reaction at cathode? It is reduction. Right? So how does oxygen get reduced? Oxygen should change into O2 should change into what? It should change into H2O. This is 0 and 2 minus. So this is reduction of oxygen. So how do I do? First balance oxygen. So this is O2, here there is. So for balancing oxygen, you always add water. So I will make 2H2. Now balance hydrogen. So what will I write here? 4H plus. And how many electrons? 4E minus. Now it is again getting in connection with alkaline medium. So I have to add, make use of OH. So how many OH will I add here? 4 OH minus. And here also 4 OH minus. So if I do all this, add it up, what will be the reaction at cathode? It will become 4E minus plus 4H2O plus O2 will become, now 4H2O and 2H2O, that will get cancelled. So this will become 2H2O. 2H2O plus O2 will become 4OH minus. This will become 4OH minus. So this is the reaction at cathode and the other is the reaction at anode. So let us write them together. So anode, what was the reaction? Anode, the reaction was H2 plus 2OH minus giving 2H2O plus 2E minus. And what was the reaction at cathode? Cathode reaction was, let me go back and check. Cathode, the reaction is O2 plus 2H2O, O2 plus 2H2O plus 4E minus, 4E minus giving 4OH minus. Now, if I want to add the two reactions, I have just exceeded my time. Just 1 minute, I'll finish it now. Here there are 2 electrons, here there are 4. So I will have to multiply it by 2. So what will this become? 2H2 plus 4OH minus will give 4H2O plus 4E minus. Now this is equation 1 and this is equation 2. To get the final reaction, what will I have to do? Add the 2. So 4E minus, 4E minus, 4OH minus, 4OH minus, and 2H2O will cancel this 4 and 2 will remain. So what will I get? 2H2 plus O2 is what? 2H2O. The final cell reaction is 2H2 plus O2 giving 2H2O. This is the final reaction. But in the process, what is happening? Electrons are generated at anode and they are being consumed at cathode. So what happens here? Here the electrons are generated. So if I draw the electrons here, they are getting generated here, right? And they are going through the external circuit, producing current because of flow of electrons. And here they are consumed. So they are coming in here. So oxygen is using electrons and the hydrogen is giving electrons. And what is produced? Water. So that is a fuel cell. So these are different types of cells that we needed to learn. So that is about all. There's another cell, the last one, that is nickel cadmium cell, which is also another secondary cell. This is also an example of a secondary cell. Okay, so now I will stop. In the next class,
Ma'am, can you show that final equation slide? ma'am?
yeah, final equation slide. Now
Yes, ma'am.
what I request all of you is, today I will upload this PPT, go through this PPT and be prepared. In the next class, we are class I am going to completely devote to doing MCQs and different questions on electrolysis. Go through your textbook. If there is anything which you have not understood or which you want me to explain, I will do that. So this is your electrolysis chapter is now over. Okay, so thank you all of you for coming today. I think I had a good strength, except the fact that you did only, Hari Raghav and Hari Haran, and sometimes he was also switching on the camera, Sanjay. Other than that, you are all having some difficulty, I understand, because of which you are not able to. But anyway, so thank you and see you tomorrow. So please revise and come tomorrow. All right. And we will do only a revision class tomorrow. Okay, then. See you. Bye.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am. Bye, ma'am.
Thank you.
You are welcome.